In today's lesson, we'll be covering electron configuration, specifically the arrow method. So in this assignment, we're going to need our periodic table to assist us. So our first example we're going to do is gallium. So we need to look up gallium on the periodic table. It's right here. It's the symbol Ga, number 31. So that's the atomic number, which also means that's the same number of electrons. And that's the number that we need to write next to the name. So gallium has a total of 31 electrons. So now what we need to do is place each electron, all 31 electrons, here in this electron configuration, starting with the first level, level 1, and moving up. Now we're going to use arrows to represent the electrons. Now the first arrow that goes into level 1 is always pointing up because it has an up spin, meaning that electron is spinning up. Now, the second electron that goes in is there's no more than 2 electrons per box. It's going to have a downward spin, okay? Because and if you remember from our notes on electron configuration, where we took on Electron University, this is a Pauli exclusion rule where they have opposite spins. So the second electron is spinning down, so that gives a total of 2. So now level 1 is filled. So now we move up to level 2, room S. S's can only hold 2 electrons total. So the first electron in has an up spin, and the second electron gives us is a down spin. So now room S is filled. Now we only have a total of 4 electrons. We have to get up to 31. So we're still in level 2, but now we're in a different kind of room, a p-type room. And there's 3 different boxes for level 2 room P. So it's basically a bigger room. We can fit more electrons in, but we still have the same rules to apply. The first electron in has an up spin. Now, basically, the second electron doesn't go in the same box. It goes in the next box. Likewise, the third electron will go into the next box as well. Because electrons, they're not going to share a room unless they have to. So this gives a total of 2, 4, 5, 6, 7. We have to get to 31. So before we can move to the next level, we're going to have to backfill. So the next electron goes in with a downspin, and a downspin. So now we have a total of 2, 4, 6, 8, 10 electrons. Now level 2 is filled. We have to still get to 31 electrons, so we have to continue to fill electrons in. We're moving to level 3, room S. Like, remember, only fits 2 electrons. First electron in spins up, second electron spins down. So this only gives us 2, 4, 6, 8, 10, 12. Continue on. We're in a level 3 still with a p-type room. First electron takes the first box, upspin. Next electron, the second box, upspin. Third electron in the next box with an upspin. We get to continue to backfill. So the next electron spins down, and spins down. So now we have a total of 2, 4, 6, 8, 10, 12, 14, 16, 18. So now level 3 is filled. We move up to level 4, room S. We get an upspin, first one upspin, second electron downspin. Now we move to level 3, room D. It's basically like the p-type rooms, except they're just bigger, but how we fill them is the same. First electron, upspin. Next electron does not want to share, so it gets its own room. So we continue placing individual electrons in their own room. Now, since we're still not at 31, so we have to backfill. So there's more electrons, so now they're going to have to share a room. And each electron has a downward spin. So they always have opposite spins. So now, this gives us a total of 30 electrons. And we'll just count just to double check. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. and we need a total 31. So we have to move. We're back to level 4, room P, and we just need one electron with an up spin.